All right, welcome back, everyone. I hope we were all able to catch the lecture for my Math 154 this morning. If you did not, I just finished uploading them to YouTube, so they should be converting, and you can get the replay, if not right after this class, within a couple hours or tomorrow or whenever you're free to. But remember to get that before next week, sooner than later, hopefully, because you have assignments that were assigned in there. Yeah. So we're going to pick up where we left off last time, and we're going to keep doing some more of those number sense problems from the week 2 homework. And like I said, I highly encourage you to go and do these as well. They will be counting as attendance for most people. And like I said, attendance doesn't mean you have to do all of them, just some of them. I'm very fair with that. I know some of you will do more than others. Some of you will do less. That's kind of like the opposite of the statement. I didn't really need to say that, I don't think, but yeah, so I already have that open over here. And like I said, we're not going to go through and do all of these. We did maybe about half up to this particular point, and we had some snafus. Hopefully, my internet's been fine so far this morning. Knock on wood. Hopefully, it'll be fine this afternoon. All right. And again, I want to remind you, actually, before we get into this, about this whole PKA stuff. Remember, PKA stands for Prior Knowledge Assessment. I'm not going to be testing you on that abbreviation, but it's important for you to know, because when you're going through your textbook, this is actually the first thing I meant to do. So if I open 1.1, well, when I just go through my textbook, first of all, you have worksheets for these. If you haven't noticed that yet, because you probably should have opened your guided worksheet for chapter 1 by now. And then there's this chapter 1 PKA worksheet. You can download and open it up. And you've got some different definitions, some properties. This is just like a lot of notes and stuff, and then similar questions. So it's kind of like a guided assignment if you wanted to do it. And I might be pulling things from this every now and then, just not yet. So scientific notation, kind of, not scientific notation necessarily, but introducing the idea of scientific notation with their exponents and the place values, because those two are very related to each other. And we kind of went over place values a little last time. Some money to give you a sense of what 10 to the negative 1 is 0.1 or 10 cents. A penny is 10 to the negative 2 because it's 1 cent or 1/100th. These aren't too crazy. Got some order of operations problems. We'll be doing something like this in the next class in 154. This is actually, I feel like this should probably be in chapter 2. It's a little more relevant then, but there's nothing wrong with doing the math of it now because it's just order of operations. But I've said that every single one of you should be able to calculate your own GPA by keeping your own grade book, and the formula for this would work. And I mean, not just for this class, but I mean all of your grades, your actual GPA. But that is still just kind of a weighted average formula, if you will. All right. When you're in your textbook, especially the first 4 chapters, I don't think there's any after chapter 4. So if I just open it up to the first page of 1.1, you see it's green, but as I go right, all of a sudden some stuff goes purple and you'll see this PKA symbol, prior knowledge assessment. So this is material that is more for the MDE 54 students, more for us. So if you're just focusing on the 154 material, a student would skip those sections, but even a Math 154 student could certainly see this and de-rust if they needed, but it's especially for us. Purple, so PKA, this is still us, and you can see it's a lot of the same stuff that are in your guided worksheets. Remember, there is a heavy tie together of the guided worksheets in the textbook. Especially in the beginning, it kind of loosens up a little by the end of the course. Hey, look, and then we're back to what we were talking about in class today, that last thing, that example of the flat screen problem that we built in Excel to get some of our answers that you'll be using for the discussion board, unless you're not my student. And then that's up to your teacher how they're doing those things. Good enough. Okay, so purple, especially at the top, and you'll have that little pKa symbol somewhere. That lets you know when you're in a pKa section of a textbook. What if you just click this prior knowledge activation for chapter 1? What if you click that? So there was actually a couple pages before the first page of the section. And they're just going over very basic number definitions, number lines, multiplying and dividing, very base concepts. But then after a couple pages of this, you get into the actual section of 1.1. So the textbook is completely blended with all this pKa stuff, again, up to and including chapter 4. Excuse me. So let's get back to our main menu. Actually, I didn't close that, did I? I did not. Perfect. So identify the place occupied by the digit 4. So these are all whole numbers. So this 2 is in our ones. Remember, there is no oneths for the decimals. We talked about that last time. It starts at the tenths. Then this is our tens, our hundreds, and our thousands. And they don't even make you type it out. Thousands. Let's see if that's right. Nice, we got it right. Insert commas as needed and then write the number in words. Oh boy, so this could be fun. Sometimes my math lab can be a little bit of a nuisance if people like to throw extra ands in there. So let's see if we can get this right on the first or second attempt. So commas, so commas go every 3 digits. If you come from another country, the idea of a comma and a period, some of them actually swap. Some people use a comma as a decimal instead. I can't think of any specific countries off the top of my head, but I know they exist. So those 3 zeros would be your first comma, so the 9's in your thousands. Then the 439 would make up the next comma section, so that 7 is your millions. And then there would not be another comma because it would have to go in front of the 8. And you don't want to do comma and then a number. So the number with comma should be 867, comma 439, comma 000. We can hit enter instead of clicking check answer. If you noticed, I did not hover over to check answer and click. Now, thankfully, they did not ask us to spell out the words. There are other courses in my math lab where they actually do, and I can't promise that they'll never make you do it, but this one was just multiple choice to keep it simple. So 867, now I have an 80s song stuck in my head, 5309. 867 439 000. So these are our ones, tens, and hundreds. These are our thousands, 10,000s, and 100,000s, and then our millions, 10 millions, and 100 millions. So 867,000, it can't be A. 867 billion, it's definitely not B. 867 million, that sounds possible. Let's see, maybe it's this one. 867 million, 439,000, and then there's no hundreds or tens or ones. So that sounds good. Let's make sure D is not right. 8 billion, nope, already wrong. They could have been a lot trickier with this, but that was pretty good. Now, something I mentioned, the word and in math for separating number sections is supposed to only be used for a decimal, which is why there is no and in any of this. But some people say 867 million and 439,000, something like that. All of those ands are technically incorrect. Now, does anyone actually care about that when they were talking out loud? No. But if for some reason you had to write that out in a homework problem yourself, that would be a reason you're getting it wrong, is because you have too many ands. The dashes between the 74 and 67s and everything, that's supposed to be optional. It should work either way. But I think most people tend to use the dashes. Here we go, finally to a more interesting problem. And let me do what I was doing last time where I do this and this. All right, so 3 squared times 2 cubed. So the way exponents work is, sorry, I've got to clear my throat. Okay, so the way exponents work are The 3 in this first number is what we call the base. The 2 is the exponent. But then in the second set of numbers after the dot, it's completely opposite. This 2 is your base, and this 3 is your exponent. So if you have anything that looks like this, b is your base, and that gets multiplied over and over and over. N is what we call our exponent. That tells us how many times to multiply something over and over and over. But you have to remember PEMDAS. You cannot forget PEMDAS. And I wrote it in a very specific way last time. We said that parentheses was a step, exponents was a step, then multiplication, division is a step, addition, subtraction is a step. There's only 4 steps to PEMDAS. If you see a division before multiplication, you do them in that order. If you see a subtraction before an addition, you do them in that order. It's not do all the multiplications and then do all the divisions. So that's going to play an important role here. So if we just had something like 5 to the 3rd, we've been talking too much today. That would be 5 times 5 times 5. 5 times 5 being 25, and then 25 times 5 would be 125. But this is not just as easy as that. It's 3 squared times 2 cubed. So 3 squared times 2 cubed. You might say, oh, we'll multiply this 3 and this 2 and make it a 6. No, PEMDAS. Parentheses come first, which there aren't any. Exponents come second. Exponents come before multiplication and division. Oh, that was weird. So you have to do the 3 squared first, then you'll do the 2 cubed, then whatever you have for both of those, you'll multiply. So 3 squared is 3 times 3, which is 9. Times, I'm going to really be explicit with these steps and leave the 2 cubed alone. Technically, I could go ahead and say that that's 8, spoilers, but let's show that. So 2 cubed, let's just do that. Over here. 2 cubed. That would be 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So this is 9 times 8. Now we can multiply those separate pieces. 9 times 8 is 72. So let's see if that'll give us our right answer. Perfect. Exponents are a way of multiplying something over and over and over and over and over. It's a great notation, especially if you had something like, I don't know, 11 to the 9th. It would be much better to write that as 11 to the 9th power instead of 11 times 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. This gets just ridiculous to have to write out. Imagine if your exponent was 11 to the 30th. Imagine if your exponent was a 30 and then you got to write 30 of those 11s. Get out of here. I'd rather just write 11 to the 30th and then my calculator handle the job from there, right? And yeah, for a bigger number like that, certainly calculators are fine. That's what they're there for. All right. Insert a less than or a greater than or an equals between the pair of numbers to form a true statement. So we have 2.434 and 2.47. Well, when you're comparing decimal numbers, you have to, oh, I never hit my enter enough. Classic mistake. I'm just gonna write everything out today. You have to compare the same digit and work your way left to right. You have to compare a hundreds to a hundreds. If they're the same, then you compare a tens to a tens. If they're the same, then you compare a ones to a ones. If they're the same, then you compare a tenths to a tenths. Some people will mistakenly think, oh, well, this number's got more, I see more numbers here, so that's the bigger number. And I'm going to say it's greater than. I'm going to check it. And it says it's wrong, and it gives me some instructions that I'll let you kind of go over on your own if you want to look at that problem. or pause this on the replay. But again, that wasn't necessarily right, and it could have been right. It could have been a lucky guess, but it's not just based on, oh, there's 4 digits versus 3 digits. It's based on you have to compare the 2 in this ones to the 2 in the ones. Now, it might be tough to see, but this is 2.47, and this is 2.434. If I maximize this, I can even zoom in. I'm holding Control, our favorite key in Excel, and using my mouse wheel to zoom in and out. So if you can't see it, boom, there it is, 2.434, 2.47. So this 2 is in the ones, this 2 is in the ones. They're the same. So we go to the tenths. This is a 4, this is 4. They're the same. So we go to the hundredths. This is a 3, this is a 7. Oh, we finally got something different. Now there could be a sequence of numbers in the middle of the same, and the very first one at the far left was different. Or maybe one of the numbers starts in the tens and one of the numbers starts in the hundreds. Then it's an automatic less than or greater than, just because one of them already has more or less whole number digits. That's a critical component. But in the decimals, it's less about how many you have. So 7 is bigger than 3, so 2.47 should be the bigger number. So we should be doing this one. I forgot I can't mark on pen right now. So that's our less than symbol. Classic way of remembering this, Cookie Monster wants to eat more cookies, so the mouth opens up to the bigger number. All right, let's pull the zoom back. Let's put that back on the side. And let's switch this to the less than symbol. Final check, so hopefully it's right. Yes, it is. Remember, if you get a question wrong through all of your checks, you can hit similar example after or when this little wrong menu would pop up. So let's do this one wrong. All the answer's 5. Stuff. I don't care what that says. The answer is 17.3. Okay, that was wrong. 136. So maybe I just want to round that to 100. A nice, even, rounded number. And I really like rounding to one significant digit in my real life when I'm doing when I'm working with numbers, just kind of testing things out. But that doesn't mean it's right, because they said around to 1 decimal place. I share the answer. In a similar question, numbers change, but you still have an attempt. You have as many attempts as you need. And again, it's not for a grade. This is for your own help, because again, a lot of you are probably here for a reason. So rounding to 1 decimal place. Remember, the trick with rounding is, I really would like this to be typing. New document, that's how we'll fix it. Enter 10 million times, scroll back up, here we go. So rounding, how do we round? If you're asked to round to to a specific decimal place, you have to look 1 place to the right where you are rounding to. I'll maximize this for now. You look 1 place to the right of where you're rounding to. If this number is 0, 1, 2, 3, or 4, you round down, which means delete the space you looked at, well as all numbers to its right. But if that number was 5, 6, 7, 8, or 9, then you round up. Which means the digit, I've written D twice, which means the digit you round to goes up by 1, and all numbers it's right get deleted. That's rounding. Rounding down would turn a number like 4.64 if I was rounding to the nearest tenth. I'm rounding where that 6 is. So here's what I like to do. I like to circle the number I'm supposed to look at. So we're rounding to the tenths, so we have to look here, 1 digit to its right. Since that's a 0, 1, 2, 3, or 4, we round down, which means we delete this number. This 4 is now gone, as well as any numbers to its right, which there weren't any. So this just turns into 4.6. Whereas if we had the numbers, say, 4.65 to the nearest tenths, we're still looking at the 5, or the hundredths place that is. That's where we look. But that tells us we should round up, which tells us that this number becomes 4.7. See, this number as well as all of them to the right of where we were looking go away, but the digit we round to gets incremented by 1. We're never going to take the digit we were rounding to and drop it. That 6 would never become a 5. It's either 4.6 or 4.7. The idea is your original number should be between these two things depending on how you round. So 4.6 anything either gets rounded to 4.6 or 4.7 when rounding to the nearest tenth. So let's see. I wish it would do this. There we go. Good enough. So now we're rounding. Ooh, that got ugly. 127.64 to 1 decimal place. I did not actually mean to use that exact pattern. That was a coincidence, or maybe it was just stuck in my brain. So because that's 0.64, the 6 is where we're rounding to, but we have to look at the 4. That's a 4, so we round down. So this becomes 127.6. 127.6. Does that look right? I'm going to check this. I knew it was wrong because I had a typo, but sometimes we get squirrely and we just type and hit enter. We get excited. I mean, how many messed up text messages have you sent in your life and then you had to send a correction because of that? Or just let them figure it out on their own. Well, this is not a let it figure it out on your own scenario. You got to correct your text. So 127.6, we get it right. There we go. Rounding to 2 decimals, so one more practice. So the 6 is in the second decimal place, so we look at the 1. The 1 tells us to round down, so the 1 and the 8 are gone, and we'll leave that as a 0.16. So 462.16. Does that look right? Let's actually take the time before we panic and hit enter. Yeah, I think that looks pretty good. We're taking our time, we're having patience, we're getting answers right, everything's going well. Round to the nearest hundredth. So last time they called it to 2 places, this time they called it to the nearest hundredth. That actually doesn't change the problem at all. You just have to know the names of your placeholders, something that's important to have. So 4 is in the tenths, 2 is in the hundredths. So the 2 says we round down. They're not always going to be round down. These are randomly generated. It's just kind of funny it worked out that way. So the 2 and the 5 go away, and we're left with 22.4. Looks good. Confirm, confirm, confirmed. No, it's wrong. Maybe that was on purpose, right? So we're rounding to the nearest hundredth. We're not supposed to be rounding to the nearest tenth. I said to look at the 2, didn't I? I rushed you on purpose. So let's take our time. Rounding to the nearest hundredth means this 2 is actually where we are. Going to round to, which means we look at the 5. Okay, so we're slowing down. We're going to get things right. I like to do those rush situations to show how we can make mistakes. And I've definitely done them unintentionally. But anyways, so we're looking at the 5. The 5 says to round up. Now we're going to get rid of that 5, but the 2 to the left of it should become a 3. So let's try 22.43. All right, let's check it again. We're supposed to round in the nearest hundredth. So the 2's in the hundredth. So we look at the 5. 5 says round up. 43. I think everything's good. We hope it's good. All right, we got it right that time. Perfect. All right, something that you're going to see constantly throughout this semester, something you saw me do last class, I believe. Maybe not today's class, Tuesday's class. converting between decimals and percents, and by that I mean the 154 class. Converting between decimals and percents is all about moving a decimal place. So it depends on which way you're going. If you're going from decimal to percent, just an arrow, it's a misspelling. You move the decimal twice to the, which way do you think? Left or right, left or right, left or right? Don't worry, we'll do it correct the first time. It's right. I'm going to give you a great way of how to remember that, in fact, very shortly. That way you're not doing that little dance. But if you're going the other way, if you're going from percent to decimal, then it's move the decimal to the left. Super special hint. The number should always look bigger as a percent. 3 exclamation marks. If you're looking at the number in 2 forms, one is a decimal, one is a percent, it should always look bigger as a percent. What I mean is if you don't write the percent symbol, that number should be bigger than the other one. It should be bigger by a factor of 100, in fact. I cannot tell you how many times I've used that to fix a quick mistake, because I'm converting, I'm thinking and writing and doing at 3 different speeds, and it's it can be a challenge for some of us, and I'm 3 steps ahead in my head, and when I write on the board, I move the decimal the wrong way. But I look at the number and I go, wait a minute, that doesn't look right with my super special hint. I ended up making a percent that looks smaller than the decimal. So then I go, oh, hold on, we got to correct that. So here's the idea. Let's say we said to convert. I'm just going to say convert so you know that it's going to be the other way. Let's say I gave you 4.5. So there's no percent symbol, which means it's a decimal. So we take the 4.5. Now, I might be doing this right. I might be doing this wrong. I'm not going to say which yet. Maybe you think you're supposed to be moving it left, and if I'm doing it wrong, I'll erase it. So we'll put our 0 there because of the filler. So now it's 0.045%. This was the decimal, this is the percent. But does that look bigger as a percent? No, this looks terrible. This number 0.045 looks smaller than 4.5, and the whole special super hint is the percent number should look bigger. Now, if you move the decimal too many times, that super special hint is not going to correct that. But just remember, converting between the two, it's always twice. You're always moving twice left or right when going from percent to decimal. That's not the case for, say, converting a fraction to something else. It's just converting between these 2 things only. So don't try and use that in other ideas. All right, so that was wrong, wrong, wrong. So let's instead do it the right way. Let's take our 4.5. Let's move the decimal right twice. Filler zeros as necessary, which says this is 450%. Does the percent number of 450 look bigger than 4.5? Yes, it does. So that means we did it correct. What if we had 0.00045? Really small number is a decimal. So we take that number, we move its decimal. Now we're in the habit, so we probably know at this point to do it 3 times to the right, correct? Correct, correct. I know I moved it the correct way, but I moved it 3 times instead of 2. I know I'm a pain with that, but I'm really just trying to liken this to you doing the homework, because when you do the homework, do you think you do it right the first time every time? I know I didn't. So write twice, which would make this number 0.045%. That percent number, it's small, but it still looks bigger than the decimal number, so that's good. Do you have to write this 0 in front of it? No. You can by hand just write 0.045%. It's just better notation to have a 0 in front of the decimal, because what if, that was weird. What if my decimal was like that? What if I just really trying to, oh no, I broke it. Remember I just said that was weird? Okay, there we go. Let me just use the eraser. The pen has an eraser button, but I swear it does wacky things when I try and use it. All right, you see how tiny that dot is? I just made a dot. If I zoomed in a whole lot, it's there. But I mean, if you did this by hand, you're never going to see that dot again. That's it for that dot. It's done. So if your dot is that tiny, maybe having the extra 0 in front of it would help you remember that it was there. It's just an idea, but again, it really is just better to do it that way. Okay. These can look weirder. What if we had, say, 0.2%? So this is a percent, so we know we're going the other way. So we write the 0.2. You don't write the percent symbol anymore. And if you go twice to the right, let's see if this is going to be correct. Maybe it is, maybe it isn't. If I go twice to the right, that means we got a filler 0, and we get 20. But does the percent number of 0.2 look bigger than the decimal number of 20? Nope. You probably imagined I was going to do that wrong. And I mean, look, the last two that were correct, we were moving right, so that definitely had to be wrong. So this was supposed to go left twice. Now you can catch it. There's a filler 0. Make sure you always get those. So this would be 0.002. The percent number does look bigger than the decimal. One more. What if we had 15,009%? So we write the 15,009. Now that number did not have a decimal originally, so guess what? You put it at the end, the far right. Now again, we just did the last one correct ultimately, so we'll follow the pattern and we go left twice, which should make this 150.09. There we go. All right, so let's see if we can get this right then. Find the percent notation for 0.26. So the percent should always look bigger. I actually like to tell myself that first because it can help me know which way to move without doing it wrong first. So we were supposed to make a percent number, so we're supposed to make a number that looks bigger than this. If I go left, it's going to make it look smaller and smaller and smaller. That tells me to go right twice, and you'll end up with 26. This is a very common type of percent to convert for us, like something like 0.07, 0.26, something with just 1 or 2 decimal places, because a lot of APRs are something like 5%, which would be 0.05, or 22%, which would be 0.22, or 7.5%, which would be 0.075. All right. So now we're going from decimal to percent. So the percent's supposed to look bigger, so the decimal goes right twice. Once we'll put it behind the 2, one more gives us a filler 0, so 20% would be the same thing as 0.2. And I think a lot of you will get used to seeing numbers like that and get used to the form, but for now, we got to practice. 31.9, this is just a lot of the same at this point, but I did a bunch of these because it's so important. All right, write an exponential notation. Well, let's see, 9 times 9 is going to be 81. Then 81 times 9 is going to be 729. And then 729 times 9, 1 carries 61. 6,561. I think that's right. I could put the comma in there if I wanted, but I'm going to leave it alone. So I think that's 9 times 9 times 9 times 9. And I check my answer, and it tells me I'm wrong. Now, I did that intentionally, although your answer is equal to the correct answer. So 9 times 9 times 9 times 9 was that. It is not in the correct form. Be sure to read instructions. How many times have I already said read the instructions? But this is the quantitative reasoning student's major issue, is reading instructions carefully enough to execute properly. So what did the instructions actually say? Write in exponential notation. So earlier, we showed you what exponential notation looked like. When we had that 3 squared, it was 3 times 3. So this is in more of an expanded form. What they want us to do is write this as like 3 squared or 5 cubed, something like that. So 9's being repeated over and over and over and over, so we do 9. Then we can hit this button right here to get an exponent, and there's 4 of them, so let's try a 4 here. Check, and that's exactly what they wanted. I cannot tell you how many times over the years I've seen students of all types, all ranges, all degrees, get questions like this wrong because they said the answer was, what was it, 6561, right? That sounds right. And you know, that is right in terms of the number, but it's not what they asked for. And it's not something you'd get credit for on a test because of that, because it's so simple. All right, here we go. Some good old-fashioned PEMDAS. Evaluate the following expression. So one more reminder of this. P, and I'll do it in multiple colors. P is your first step. E is your second step. Exponents, parentheses exponents. M and D, in the order you see them, from left to right. If you see divisions before multiplications, do divisions before multiplications. And then finally, addition and subtraction. So that was step 4, step 3, step 2, step 1. 4 steps, get it right, please and thank you. So 8 plus 5 minus 3 minus 2 times 3. I'll stick with their X instead of a dot. So we have an addition, several subtractions, and a multiplication. There are no parentheses, so that step is done. There are no exponents, so that step is done. I'm going to erase those slashes in a second. There is a multiplication. There aren't any divisions, though, so we can't really get that in the wrong order, hopefully. So step 3 is just doing the 2 times 3 being 6. And then we'll be done with that step. And then all we're left with is the additions and subtractions from left to right. So this, so far, is 8 plus 5 minus 3 minus 6. That's the only step I've done going through step 1, step 2, and all of step 3. But step 4, the additions and subtractions. We do not do the addition first because it's an addition. We do it first because it's furthest to the left. So we just do all of these in the order seen from left to right. I actually wish that the first one was a subtraction and then an addition so that we'd be doing a subtraction first. But that's the fun of randomly generated problems. So 8 plus 5 is 13. Then 13 minus 3 would be 10. And 10 minus 6 should be 4. Let's see if we get it right. We got it. There's more of these. Let's scroll to here. So we got 39 minus 12 times parentheses 19 minus 4 squared. Now this little times right here, this is completely unnecessary to write by hand. Some calculators you have to do that. If you've got a graphing calculator, you usually don't have to. If you've got a scientific calculator, you usually have to type that times before you do a parentheses. So this is another case of you have to learn your technology. All right, so we have a subtraction, a multiplication, a parentheses, another subtraction, and an exponent. So out of that PEMDAS, parentheses first. So there's a parentheses, so we're narrowing our field of vision to just inside here until that's done. Now inside of that parentheses, guess what? You still follow order of operations in there. So you have a subtraction and an exponent, you've got to do the exponent first. So this exponent will come first because it's inside of a parentheses. So this will end up being 39 minus 12 times, so all we're really doing here is this 4 squared. Notice I'm not including the minus, and I'm going to give you an example of 2 very different examples and how they get very different answers. But the minus is not part of this exponent. Let me show you the only way it would be. If it looked like this, please pay attention. Sorry about that if you heard my doorbell. Let me make sure that's not a family member. Okay, we're good. Sorry about that. Distractions at home. I know you know all about it. Thank you for your patience, per usual. Love you all. All right, so if you had a parentheses around the negative in the number, this would be a very different thing than what I'm about to do. Because the way exponents work, this exponent does not count the negative as repeating. So, little memo here, this is not part of the exponents. This will be a critical issue throughout the semester. So that is really just 4 squared, not negative 4 squared. So 4 squared is 4 times 4, which is 16. So that's 19 minus 16. And then we're done with that first step. We still have a parentheses though, so we're still narrowing our field of vision in here. And again, after this example is done, I'm going to show you what I'm referring to about the difference there. All right, so only one step, 19 minus 16, that's 3. So this is 39 minus 12. Now, you could do it this way. You could leave the 3 in parentheses. Please understand this no longer counts as a parentheses though, because there's no operations to do inside of it. What this does for us now is it's saying to multiply the 12 and the 3, or that negative 12 and the 3. This is especially helpful if this number was negative. Let's pretend for a hot second this was negative. You would definitely want a parentheses if it was negative. Otherwise, it just looks bad. Let me show you what I mean. So if it was 12 times negative 3, that just doesn't look good. So since it's positive though, it's perfectly fine to eliminate the parentheses and do it this way. So I've given you 2 different ways you could have written this. If it was a negative number, I'd say the parentheses way would be critical to do. All right, so the next thing we do, and I might be pulling out red for a reason, hint, wink, nudge. Next thing we do is 39 minus 12, which is 27, right? 9 minus 2 is 7, 3 minus 1 is 2, so that sounds good. And then we have our 27 times 3, and 27 times 3 is going to be, what's that, 81? Yeah, 81. I don't know why I had to think about that for a second. Question mark, question mark, question mark. Let's see what we get. Nope. Evaluate the expression using the proper order of operations. So the hints aren't always as great for some problems, but it did at least remind you to do everything in the proper order, which is exactly what we did wrong, why I switched to red here. What did I do wrong? I did a subtraction before I did a multiplication, and this is what people on Facebook do. No, that was bad. We were supposed to follow PEMDAS in the 3rd step of PEMDAS. We already did our parentheses. There were no exponents. We're supposed to do multiplications and divisions. So we were supposed to do this first. This 12 times 3, which is 36. So we get 39 minus 36, which is 3. I'm trying to pen over here. Can't do that. So let's see if the answer is 3. Hot dog. We got it right. Oh, look, another one. Before we do this one, let us explain that whole exponent situation. So this is an exponent issue. If you have something like negative 3 squared versus negative 3 squared, but one of them has a parentheses. The first one, I've already talked about how the negative is not repeated. And in fact, I'll do the negative for this one in a different color. So the negative is not repeated, it's the 3 that gets squared. So that's 3 times 3. The exponent does not apply to a negative unless it's wrapped in a parentheses like the second case. In this one, it is negative 3 times negative 3. You technically don't need the parentheses around the first one, but most people put it anyways. And look at the answers. The first one's going to be negative 9. Negative times a positive is a negative. And the second one's going to be a positive 9. Now, if these are odd exponents, it's it's admittedly less of an issue because you're coincidentally going to get the right answer no matter what. But when they're even exponents, this is a problem. And even though you'd think it's 50% even, 50% odd, I would say we see more even exponents than odd exponents in this course. So that is an issue that will pop up every now and then. So please, please understand that. This is not just an issue that QR students face. This is an issue that up to calculus students face, and we'll do this wrong every now and then. All right, so 4 squared, 4 squared plus 2 times -4 minus 8 plus -5 times -3. So we have parentheses. Do we have multiple parentheses? No, in fact. This is the only one that counts as a parentheses because this is a single number, this is a single number. These are just used to wrap up negative numbers and multiply them. So we're going to do the parentheses first. So we leave the 4 squared alone. We leave the 2 outside alone. -4 minus 8, same sign, add the numbers, keep the sign, makes -12. We talked about that last time or 2 times ago, I think last time. Since it's still a negative, I'm going to leave it in parentheses to show the multiplication. And then plus the -5 times the -3. So now our parentheses are done. We're up to exponents. The 4 squared is 16. So 16 plus 2 times -12 plus -5 times -3. Now our exponents are done, so we're up to multiplications and divisions in the order seen from left to right. Here's a multiplication, here's a multiplication, do them from left to right. Leave the 16 alone. 2 times -12 is -24. Now you can either write this as plus -24, or you can write this as, in my opinion, the more preferred way at our level, -24. Adding a negative is the same as subtracting a positive. Now, because of the separation, you can actually do this product right now, but I'm just going to be very meticulous with my step orders. So that's 16 minus 24. -5 times -3 is positive 15, so that'll be plus 15. See, if you did them all in one step, if you said it right here, -5 times -3 is positive 15, then instead of writing that, you could just go ahead and write 15, and it's one less step of work. If you feel confident, you can take that. If you don't, if you're not sure why it is that you can do those together, then take the extra lines. So now we have a subtraction and an addition, and this is where people on Facebook start arguing. This is where some students start arguing. Do the addition, PEMDAS, MDAS. A comes before S, so this should be first and this should be second, right? Question mark, question mark, question mark. No, no, wrong, bad, stop it. Addition and subtraction are two sides of the same coin. You do them in the order seen from left to right. So you actually do the subtraction first. 16 minus 24 is -8, because 24 minus 16 is 8, the larger sign is negative. So then we have -8 plus 15. -8 plus 15, well, we do 15 minus 8, which is 7. The larger sign this time is positive, though. So our final answer should be 7. Let's see. If I made a mistake somewhere, it wasn't intentional. Okay. All right, if you can't see, oh, the zooming in was a little too wild there. That is a division between the -6 and the first -3. So that's -6 divided by -3 times -3. This problem is great because it's just emphasizing kind of what we just went over at that very last step. So that's -6 divided by -3 times -3. Some people say, oh, PEMDAS, P-E-M-D-A-S. M comes before D, so we do this. I'll pull out the red this time to really emphasize that it's wrong first, and this second. But again, wrong, wrong, wrong. M and D, two sides of the same coin, do them in the order seen from left to right. So we do the division first. -6 divided by -3 would be +2. So again, what I have done so far was this. That -6 divided by -3 gave us the 2. I just brought the -3 down. Now that's 2 times negative 3, which is negative 6. Cool. Here we got one written as a fraction. I believe last time we talked about how if you have a bunch of steps in a top and a bottom, to do them all separately, you can even give them their own PEMDAS independent of each other. And you only want to cross that division bar once it's just a single number in the top and a single number in the bottom. No more steps to do. So we got 3 times negative 0.4 squared all over negative 4. So there's an exponent. That is not a parentheses. It does not count as a parentheses. Now that negative is inside. So like earlier, that means you're doing the negative repeated, and a negative repeated twice will be a positive. If you're rusty with your decimal multiplication, it goes like this, 0.4, 0.4. You actually do what's called a right alignment. I know it looks like I lined up the decimals. I did not. I right aligned the digits. For example, if I wanted to do 3.5 times, I don't know, 2.687, it would look like this. See, that's a right alignment. So here's what you do. You multiply these numbers like the decimal isn't there. 4 times 4 is 16. And you might say, all right, well, now I got to multiply by this digit, but that's a 0, so it's pointless. Then what you do is you count up the number of decimal places. There's 1 decimal from the first, there's 1 decimal in the second, and then you add those up, saying that there's 2 decimals, 2 deads, 2 decimals in the answer. So you make sure it has 2. So the point would have to go in front of the 1. So that would be 0.16. So this is now 3 times 0.16. Again, a negative times a negative makes a positive, divided by negative 4. 3 times 0.16, again, if you want to, I actually like putting the longer number on the top. 6 times 3 is 18. And again, calculators are fine, but it's good to have these skills by hand. 1 times 3 is 3, plus the 1 is 4, so we get a 48. There's 2 decimals, there's 0 decimals, which means we need 2 in the answer, so that would be 0.48. So this is 0.48 divided by negative 4. And dividing a decimal by a whole number is easy. You just put the 4 on the left, the 0.48 on the right, put a decimal directly above it. If this 4 was a decimal, I would just say go ahead and do your calculator, or know that you have to move the decimal right to make this whole, and then do the same to the other number. 4 will go into 0 0 times. 4, and we're pretending these decimals aren't here anymore. 4 will go into 0 4, which is 4 once. 1 times 4 is 4. Subtracting, you get 0. Bring down the 8. 4 will go into 8 twice. 2 times 4 is 8. Subtracts perfectly. So the answer is 0.12, right? Well, that's close. It's very close, but be careful. A lot of people, after they do work like that, they'll forget about the sign issues. Positive divided by negative is a negative 0.12. Where'd we go wrong? Oh, I see why. That was not an intentional mistake. I typed my negative and it didn't register. I had to look. Negative 0.12. See, I had my answer right, but I typed it in wrong. It told me I was wrong and I had to go, oh, what happened? I was checking the numbers in my head. I asked what made sense. I was like, no, all this is right. I did this right. Then I carefully looked here and I noticed my negative was missing. I like making actual mistakes along the way because you get to hear my brain process it, but I also like making those fake mistakes because I feel like it makes you understand that we're all doing the same thing, that nobody's perfect, but we have to get it right ultimately. Nobody's perfect on the first try. I think that's a better way of saying it. All right, and this will be the last one for the day. Negative 15 times 4 plus negative 2 squared minus negative 4 times 3. PEMDAS, 4 steps, not 6. there's nothing that counts as a parentheses because there's just single numbers inside of them. But we do have an exponent. Negative 2 squared, that's negative 2 times negative 2, which is positive 4. So negative 15 times 4 times this 4 right here was the negative 2 squared. Then I got a minus a negative. Minus a negative, please make that a plus. So that's another 4. A lot of 4s in there, times 3. So our exponents are done. Now we're up to multiplications and divisions. There's 2 multiplications. Do them from left to right. I will mention that we have that separation by a plus sign, so we can do all of these at once if you would like, but again, I'm going to be meticulous and do it step by step. Negative 15 times 4, let's see, 15 times 2 is 30, times another 2 is 60, so that's negative 60. Then times the second 4 that was up there, plus the third 4 times the 3 at the end. Then negative 60 times 4, well, 6 times 4 is 24, just tack on the 0. Negative 240. Plus 4 times 3. We're not doing another multiplication of 4 though, because that's a plus. So we're going to switch over here, do 4 times 3, which is 12. And then finally, we have an addition as our final step. Finally. But that counts as subtraction in the process. 240 minus 12 is going to be 228. But the larger number is negative. Remember, when I say larger, I mean an absolute. Technically, the 12 is bigger than negative 240. But when I'm doing that comparison, I'm only comparing the 12 and the 240. So negative 228. That's incorrect. Where do we go wrong? So we said our 15 times 4 was 60. Our 16 times 4 was 240. We had our this became a plus 4 at the end. 4 times 3 was 12. problem right. Negative 15 times 4 plus negative 2 squared minus negative 4 times our 3. 4. I see what happened. This was an actual mistake on my end. What is this? That's a plus sign between that 4 and what is going to be a 4 in the future. What did I turn it into? A times. These were not the same thing. So that means we have to start from scratch almost, just start from line 2. So this was wrong. So let's just do it over here. Now this step was right, negative 15 plus 4, no, 15 times 4. Then the plus 4. Then the other plus 4 and the times 3. I probably just was reading and writing at 3 different speeds. You've heard me say that before. I apologize. So then the negative 15 times this first 4 should be a negative 60, but then we have a plus 4 times 3. That 4 times 3 is still 12, so negative 60 plus 4 plus 12. Now we do our additions. Negative 60 plus 4 would be negative 56. Different signs, subtract, keep the sign of the larger, and then plus our 12. Once again, different signs, so we subtract and keep the sign of the larger. 56 minus 12, well, 6 minus 2 is 4. 5 minus 1 is 4. So negative 44. Let's see if we can get it right on the second try. Drum roll. There we go. Got it. So this is why we have to be careful and we have to pay attention and not rush. Sometimes it's a little more challenging when we're multitasking. I know we're all in that situation every now and then, as I just showed you. But sometimes multitasking leads to mistakes. But when we make mistakes, we have to learn to correct them. We have to learn to find where the mistake was. That's a critical skill. Otherwise, you just go back from the start and see if you can figure it out. So if I hadn't found that mistake, going back to the start and doing it again, we would have got the answer right. And then I could have gone back and compared and said, oh, nope, yep, I had a typo there. I messed up. I went too fast. So you've pretty much seen all of the different homeworks from that assignment. But remember, there is another separate section for week 2. And this is the type of stuff that, like I said, I won't always be covering inside the class. Sometimes I will, sometimes I won't. I won't go over all of them. You don't have to do all of them, but these can be very, very helpful, very often multiple choice. What is one service provided by student services? Do they offer childcare? Oh, wow, many student services offer childcare. If you had tried to do, computer's locking up. I think that says it's about time to end class. Let's hold on for a second. Anyways, all 4 of these might have seemed like good, solid options. Math tutoring, that sounds like it might be part of student services. Scholarship information, career counseling, but no, they're not actually in that department. Is that critical for you to know to make straight A's? No. Is it something that might help you know how to locate other materials and sources of things? Yeah, possibly. And let me close that. Maybe that'll help. Let's try and just reopen it. All right, cool. Marcus must study hard to do well in school. Which internal motivation will help Marcus reach his goals? In college, probably to get a job, probably to make more money. Some of us are just looking for growth, though. Our motivation factors are very different from person to person, but it's usually money, I find. To set up a family, get a house, find happiness, because money's not going to buy you happiness, but it can buy a Ferrari, and you never see someone in a Ferrari with a sad face, right? That's the joke. All right, so what internal motivation could help? And this will be the last one we'll do together, because you get the point. Working for good grades, pleasing his parents, preparing for a career field, or wanting recognition from peers. So it says internal motivation. Maybe that has something to do with it. Prepping for a career. Maybe it's working for good grades. Maybe that's the motivation to do well. Instructors are a large factor in final grades. Marcus should choose an internal motivator. So pleasing his parents. Well, that kind of sounds like it might be in line there, that there's some external things. So preparing for a career field or wanting recognition from peers. Wanting recognition, again, that kind of sounds external when you think about that, what they gave you as a hint. So it's probably preparing for a career field, which, you know, was going in line with what I said to begin with, hinting at this. Money, money, money. Career, money, family, happiness. All right. So we're going to call it a day there. If you have any questions.
All right, I thought that would just be a fun little interactive thing to do in the middle. I might try that again at some point, but like I just said, we're going to call it a day there. So we know what we have on the docket in terms of assignments, the chapter 0 Excel file, then the first My Math Lab homework, the first Excel homework, and then the discussion board for the 154, and then just make sure that you are keeping up with some of the assignments from MDE 54 from this class, because it is required. All right, so take care everyone, and we will see you next time.